This is SpaceTime Series 27, Episode 15, for broadcast on the 2nd of February 2024. Coming up on SpaceTime, could changes in atmospheric pressure be driving Mars's methane pulses? Can red dwarf stars host planets with life after all? And Axiom Mission 3 blasts off to the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New research shows that atmospheric pressure fluctuations, which pull gases up from underground, could be responsible for releasing subsurface methane into the Martian atmosphere. The new findings, reported in the Journal of Geophysical Research Planets, could help solve one of the red planet's enduring mysteries, the seasonal detection of methane in the Martian atmosphere. Importantly, knowing when and where to look for methane could help Mars's Curiosity rover in its search for signs for life. You see, here on Earth, methane is primarily produced as a byproduct by living creatures ranging from bacteria to cows. So, detecting it on Mars has sent some scientists into a flurry. Now, no one's expecting to find bovine inhabitants on the red planet, but the fact that it's happening seasonally and usually in warm conditions does raise the possibility of bacterial life. The problem is, methane can also be produced by geological processes, and telling the difference is hard. The study's lead author, John Ortiz from the Los Alamos National Laboratory, says understanding Mars's methane variations has been highlighted by NASA's Curiosity team as the next key step towards figuring out where it's coming from. But there are several challenges associated with meeting that goal, and a big one is knowing what time of a given sol or Martian day is best for Curiosity to perform its atmospheric sampling experiment. A primary focus for NASA's Mars missions, including both Curiosity and its sister rover Perseverance, is to detect and understand past or present signs of life, such as methane. However, with the source of methane on Mars being underground, short-term variations in atmospheric methane levels have posed a research challenge. To better understand Mars's methane levels, Ortiz and colleagues used high-performance computing clusters to simulate how methane travels through networks of underground fractures, eventually to be released into the atmosphere, where it then mixes within the Martian atmospheric air column. They also modelled how methane can be absorbed onto the pores of rocks, and that's a temperature-dependent process, which may be contributing to methane fluctuation levels. Their simulations have predicted that methane pulses from ground surface into the atmosphere just before Martian sunrise in the planet's northern summer season, but that's just ended. Interestingly, this corroborates previous rover data, which was already suggesting that methane levels fluctuated not just seasonally, but also on a daily basis. The data will help Curiosity mission managers' ongoing sampling campaign because it suggests several key time windows for Curiosity's collection of data. The authors think these offer the best chance for constraining the timing of methane fluctuations and hopefully bringing them closer to understanding where it comes from on Mars and what's causing it. This is SpaceTime. Still to come, a new study suggests that red dwarf stars could possibly host planets capable of supporting life. And the Axiom Mission 3 arrives at the International Space Station. All that and more still to come on SpaceTime. Okay, time to take a break from our show for a word from our sponsor, NordVPN. We use NordVPN at SpaceTime because we know it's good, and we were using it before they became sponsors of ours. Today's digital universe is vast and ever-expanding, just like the cosmos we explore here on SpaceTime. But as you navigate this digital space, how secure really is your journey? And that's where NordVPN comes in. Picture NordVPN as your spacecraft, shielding you from cyber threats and ensuring your journey online is safe and private. NordVPN is the tool you need in your digital toolkit. Did you know that NordVPN encrypts your internet connection, making it virtually impossible for hackers or any other bad actors to intercept your data? It's like having your shields up with an unbreakable force field around your online presence. Plus, with access to over 5,200 servers worldwide, you can enjoy lightning-fast internet speeds and unlock content from across the globe. And here's the best part. As a SpaceTime listener, we have a special exclusive offer for you. Not only do you get a great price, but an extra 4 months free with any package if you use our special URL. So, visit nordvpn.com/StuartGary in order to get a special deal on NordVPN's great services. Remember, with NordVPN, your online journey isn't just about reaching your destination, it's about ensuring a safe passage through the digital cosmos. Join the ranks of the security conscious and make NordVPN your choice for safer, faster, and a more open internet experience. Visit nordvpn.com/StuartGary for our special offer. And of course, you'll find the URL in the show notes and on our website. Secure your space in the digital universe today. You won't be sorry with NordVPN. And now, it's back to our show.
This is SpaceTime with Stuart Gary.
A team of scientists are proposing that rocky Earth-like planets orbiting some of our nearest neighbouring stars could support life. And that's highly controversial. See, when rocky Earth-like exoplanets were first discovered orbiting in the habitable zones of some of our nearest neighbouring stars, excitement rocketed. It was until hopes for life were dashed when it was realised that these stars were usually spectral type M red dwarfs. Stars which produce high levels of radiation which would bombard these otherwise potentially habitable worlds. A good example is Proxima b. It's a rocky Earth-sized planet orbiting around the star Proxima Centauri, which is the nearest star to our Sun. It's only 4.24 light-years away. Proxima b orbits in the habitable zone, the area around a star where temperatures are just right for water to exist on a planet's surface in a liquid form. Thereby, if there's enough atmosphere, it could pool there, giving life a chance. The trouble is, Proxima b receives 250 times more X-ray radiation than Earth and could also experience deadly levels of ultraviolet radiation on its surface. So, how could life possibly survive under such bombardment? Well, according to a team of Cornell astronomers, they say life has already survived exactly this kind of fierce radiation. And the proof is you. Lisa Kaltenegger and Giacomelli James have made their case in a paper they've published in the monthly notices of the Royal Astronomical Society. They say that all life on Earth today evolved from creatures that thrive during an even greater ultraviolet radiation assault than what Proxima b and other nearby exoplanets are currently enduring. They point out that 4 billion years ago, planet Earth was a chaotic, irradiated hot mess. Yet in spite of this, life somehow gained a foothold and then expanded. Kaltenegger and O'Malley James say the same thing could be happening right now on nearby exoplanets. For their study, they modelled the surface ultraviolet environments of 4 exoplanets closest to Earth that are potentially habitable, namely Proxima b, TRAPPIST-1e, Ross-128b, and LHS-1140b. These planets all orbit small spectral type M red dwarf stars, which unlike our Sun, produce frequent stellar flares, bathing their planets in high-energy ultraviolet radiation and X-rays. Now, while it's unknown exactly what kinds of conditions prevail on the surface of these planets, it is known that such flares are biologically damaging and they cause erosion of planetary atmospheres. High levels of radiation cause biological molecules like nucleic acids to mutate or even shut down. O'Malley James and Kaltenegger modelled various types of atmospheric conditions, ranging from ones very similar to present-day Earth to eroded and anoxic atmospheres, those with very thin atmospheres that don't block ultraviolet radiation, and those without the protection of an ozone layer. The models showed that as atmospheres thin and ozone levels decrease, more high-energy radiation can reach the ground. The authors then compared their models to Earth's history from nearly 4 billion years ago right through to today. Although the model planets received higher UV radiation than emitted by our Sun today, this is still significantly lower than what the Earth received 3.9 billion years ago. Kaltenegger says that given that the early Earth was inhabited, the study shows that UV radiation should not be a limiting factor for the habitability of planets orbiting spectral type M red dwarf stars. She says that means our nearest neighbouring exoplanetary worlds remain intriguing targets in the search for life beyond our solar system.
We live in this amazing time where we found thousands of other planets, planets that don't orbit our own sun, but other suns, other stars that you can see in the night sky. And the next one over after our sun is actually a small red star called Proxima Centauri, and even the next star, in only 4 light years away, has a planet that could potentially be like an Earth at the right distance, so it's not too hot and not too cold for there to be liquid surface water. So the big question that arose when looking at this young red sun is whether the harsh UV radiation that it flings out at its planet would actually be detrimental to life starting to evolve there. And what we figured out is when we calculated how much of this harsh UV radiation would make it to the ground on that planet, is that it would be worse than currently on Earth. So for you and me, it wouldn't be the best place to be, but it's less than it was on a young Earth. And on a young Earth, we had life. So the chances to finding life close to us, around the closest stars that happen to be red young suns, is much greater now. And so our quest to figure out whether we're alone in the universe just got a tiny bit easier.
That's Lisa Kaltenegger from Cornell University. And this is Space Time. Still to come, the Axiom 3 mission arrives at the International Space Station, and later in the science report, claims the giant shark megalodon was a lot slimmer than previously thought. All that and more still to come on Space Time. SpaceX has launched another private manned mission to the International Space Station for Axiom Space. The mission, carrying an all-European crew, were flown aboard a Dragon capsule on a Falcon 9 rocket from Pad 39A at the Kennedy Space Center in Florida.
Falcon 9 is in startup.
Confirmation that Falcon 9 is in startup and Dragon is in countdown, which means that the vehicles are now controlling the final seconds as we lead up to liftoff.
Dragon, SpaceX, go for launch.
And there's confirmation from our flight director.
Go for launch.
We are go for launch.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, engine full power, and liftoff. Go Axiom 3.
Further beyond, opening the door for more to follow. Godspeed AX3.
Stage 1 propulsion is nominal.
This is the launch of the Axiom 3 launch to the International Space Station. Now in just a few seconds here, we should hear the call out that Falcon 9...
power and telemetry. Stage 1 throttle down.
There's that call out that Falcon 9's engines are throttling down to help us pass through the period of maximum dynamic pressure during ascent.
Max Q.
There's that call out for Max Q.
Falcon 9 is supersonic.
And that Falcon 9 is going faster than the speed of sound. Now at this point, we will begin to throttle Falcon 9's engines back up.
Stage 1 throttle up.
There's that call out for mission control as well, as our AX3 crew continues on their way to space.
We're now T plus 1 minute and 32 seconds into flight. The next event we have is MVAC chill, similar to what...
MVAC chill underway.
There's that call telling us that, again, we're flowing a little bit of that super chilled liquid oxygen.
Stage 1 Bravo.
Copy 1 Bravo.
That call there was one of the abort mode call-outs that the crew is calling out as they are making their ascent on Falcon 9. Now, we're less than a few seconds away from 4 events that will happen in rapid succession: main engine cutoff, or MECO, stage separation, ignition of the first stage engine, and the first stage's boost back burn.
Stage 1 throttle down.
That call telling us that the engines are beginning to throttle down.
MECO. Stage separation confirmed.
SpaceX Dragon 2 Alpha.
Some loud cheers here as the
Stage 1 boost back startup.
first and second stages have separated. That first stage booster is now heading back toward the Florida coast. Note that that first stage is actually still coasting to its apogee. So it's about 114, 115 kilometers above the Earth's surface. And it's going to keep coasting for a little bit.
Stage
back
1
engine.
boost back shut down.
All right, that boost back burn has concluded on the first stage. Everything looks nominal with the second stage trajectory. Everything also looking good.
Dragon SpaceX trajectory nominal.
Everything looking good on the first stage as well. Grid fins begin to deploy.
SpaceX Dragon loud and clear.
Now, the next two major events we're tracking for the first stage is going to be the entry burn at about T plus 6.5 minutes, where we'll light 3 of Falcon 9's first stage engines, followed shortly thereafter by the landing burn at T plus 7 minutes and 32 seconds, which will be a single engine burn to bring us back to landing zone 1 at Kennedy Space Center. At this point, we should be just about a minute and a half away from that entry burn
Dragon
start.
SpaceX trajectory nominal.
Good call-outs there that we continue on a nominal trajectory with Dragon.
SpaceX Dragon, we copy.
And acknowledgement from the crew. That entry burn we're waiting on here is going to be a relatively quick burn, and what we're doing with our first stage is effectively scrubbing off some of that velocity as we come in for landing.
Dragon SpaceX trajectory nominal.
That's a nominal trajectory for Dragon as we continue to orbit.
SpaceX Dragon, we copy.
Again, confirmation from the crew.
Stage 1 entry burn startup.
And we are expecting about 2.5 more minutes from that second engine burn.
Stage 1 entry burn shut down.
As we heard the call out, that entry burn has concluded. The next burn will be the landing burn. As I mentioned before, we're heading back to landing zone 1. We're going to come through the clouds right now.
Dragon SpaceX trajectory nominal.
Everything continues to look nominal
SpaceX Dragon, we copy.
for the second stage there. There it is. Just like magic, we see landing zone 1. Crowds cheering here at SpaceX Mission Control Hawthorne. And if you couldn't tell by the loud cheers, we did
Stage
stick.
2 STS is saved.
We did stick that landing. Falcon 9 has landed once again. But turning our attention back to the crew, our next event is second engine cutoff, or SECO. Second stage will coast for a few minutes until Dragon is commanded to separate. A lot of just the energy here at SpaceX Mission Control is buzzing. You can hear commentary behind us. Right now, the crew is experiencing about 3 Gs. So pretty much a roller coaster for those thrill seekers out there.
Stage 2 is in terminal guidance.
And we are about 20 seconds away from that second engine cutoff. MLA will know this feeling very well, this experience of going from now almost 4 Gs to...
SpaceX Dragon Shannon.
Copy, Shannon.
As another abort mode there being called out. Now standing by for second engine cutoff.
Invec shutdown. Dragon SpaceX, you're in a nominal orbit.
Axiom Mission 3 is the company's third launch to the International Space Station, and the first at which all 3 passengers were members of national space agencies rather than wealthy space tourists. The 4-man Axiom 3 team is spending 2 weeks working with the 7 crew members now on station to undertake a total of 30 experiments. These will range from the impact of microgravity on the human body to new industrial processes that seem to work better in space than on Earth. Included is a bone health experiment, which look at how quickly bones start to lose density in microgravity and how long it takes them to recover once back on the ground. There's an orbital architecture study that'll explore how the design of space habitats affects an astronaut's thinking and stress levels. Another experiment will focus on how microgravity triggers changes in cellular structures and gene expression. The crew will also monitor how they sleep in orbit, looking for differences in sleeping patterns and brain activity in space compared to on the ground. Then there's the Thor Davis experiment. It'll monitor thunderstorms and lightning shooting upwards towards space using a special new camera designed to film 100,000 frames per second. The Davis camera is an event camera, which works in a similar way to the human eye. It sees changes in contrast instead of capturing an image like a regular camera. The team will also monitor heart rate, brain activity, sleep quality, diet and exercise routines to see how they cope with the new environment, looking at working memory, reaction time, attention and organization. Founded in 2016, Axiom Space was contracted by NASA to develop the next generation of spacesuits for astronauts for use on the lunar surface EVAs, that's extravehicular activities or spacewalks in NASA speak. The company's also been developing its own space station modules, which will initially be attached to the current International Space Station before later forming the core of their own new privately operated commercial space station. That should be operational before the International Space Station's retired in 2030. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has found that people who show strong obsessive-compulsive disorder traits have an 82% higher risk of death. The findings, reported in the British Medical Journal, are based on health data from almost 700,000 Swedish people either with or without obsessive-compulsive disorder. The authors also looked at the health data of more than 80,000 siblings with or without OCD as a comparison. Now, obsessive-compulsive disorder isn't the case of simply making sure that all your shirts face the same way in your closet. It's a chaotic and often disabling psychiatric condition where someone has intrusive thoughts that trigger high levels of anxiety, obsessions, which the person tries to neutralize by engaging in repetitive behaviors or rituals or compulsions. Previous research had mostly only looked at the psychiatric disorder, as well as links to unnatural causes of death, such as suicide and accidents. But little is known about natural causes, such as cardiovascular disease and diabetes. A new study has found that Cacaricles megalodon, the extinct 20-metre-long monster shark long thought to have been related to Carcharodon cacarius, the great white, may not have been quite as massive as originally thought. A report in the journal Paleontologica Electronica has just published an analysis of a fossilized megalodon vertebrate column, finding that it had a surprisingly small diameter. Assumptions about the body shape and size of megalodon were previously based mainly on looking at its massive triangular and serrated teeth and huge jaw, which appeared, initially at least, to be sized-up versions of those found on great whites. Great whites, also known as white pointers, average around 5 metres, but have been recorded up to 12 metres in the scientific literature. For comparison, Bruce, the mechanical shark in the movie Jaws, was around 6.5 metres. Scientists figure that megalodon may have simply been an overall sized-up version of the great white, which has a stocky body shape. However, the slim vertebrate column now suggests that it was a much trimmer version than the white pointer. North Korea claims it's just tested an underwater nuclear weapons system. Pyongyang says it tested the Haeil-523 nuclear system in the East Sea of Korea. The unconfirmed test appears to be part of a growing escalation in military aggression by the communist dictatorship. Last year, Pyongyang said it carried out multiple tests of an underwater nuclear attack drone, a different version of the Haeil, which means tsunami in Korean, claiming it could unleash radioactive devastation. The hermit state also launched a solid-fueled hypersonic missile last year and staged a series of live fire exercises near the country's tense military border with South Korea. Pyongyang also recently just launched a new spy satellite into orbit with help from Moscow. That was in exchange for supplying arms and ammunition to Russia for its ongoing invasion of Ukraine. Over many decades, scientists have tested and we've reported on the many different effects of drinking coffee. We've looked at everything from cancer and life expectancy through to skin complexion. Now, they've just released a new study which looks at the effect of coffee on your weight, finding that it could help slow down long-term weight gain. However, before you get too excited, Tim Mendham from Australian Skeptics says the study was so badly constructed that the findings are next to useless.
This is a study that was done using a lot of people. It actually sort of looked at some previous studies and gathered the data from them. One was about nurses' health covering a period of 30 years or so, and that involved surveys that were done over about 230,000 people. So it's a very decent sort of size subjects. And these surveys were done over the years, and they were asking people various things about their health and their diet. And what they found is probably one of the most niche, extreme, obscure factors that you could possibly think of. What they found out was that there's a modest link between coffee and gaining less weight than expected. In other words, you're still going to gain weight as you get older, but you'll gain slightly less weight if you drink coffee. The trouble is if you put sugar in the coffee, that sort of counteracts some of that thing. Eventually, what they're saying is that people who drink an extra cup of coffee, I don't know what extra means. If you drink 15 cups of coffee a day, the 16th one's going to make a difference. Anyway, people who drink an extra cup of coffee a day gained 0.12 kilogram less weight, still gain weight, but 0.12 of a kilo less weight than expected over 4 years. Now, over 4 years, that's 0.03 of a kilo, which is, 30 grams per year. 30 grams per year, which is not a lot to measure over a period of time. And as I sort of worked it out basically as a quarter of a quarter pounder.
You and I are both journalists, and you and I both know that coffee's our friend.
I don't drink that much coffee, I must admit, but I don't have the effect. I don't get the coffee stimulus. I can have a coffee before going to bed and I'm fine, right? So it just doesn't have the effect on me. But what they do say, and they admit, was there are some problems with their own survey. One is that it shows association, not causation, not necessarily one causing the other. Second, they point out that the findings about the weight are very modest, which is subtly put. The average 4-year weight gain averted based on 1 cup of coffee is 0.12 kilos, 30 grams a year, and they say that's insignificant amount. It doesn't make a lot of difference. They also point out that it doesn't look at the variability and the amount of caffeine in the coffee. You can have a low caffeine coffee, you can have a high caffeine coffee, you can have tea, etc. It's got caffeine in it. So all they're saying is, did you have a cup of coffee? So in other words, what they're saying is that the number of people in the survey, that the association is unreliable, the weight gain is insignificant, and the actual basis of the survey is unclear and not catered for.
Well, I think it's just one of the things they wanted to look at. This nurses survey across the United States, this is one of the most complete bodies of work looking at how humans change over time that's ever been put forward. It's a massive survey. There are so many different things that have been coming out of it over the last 10 years.
When you have a survey as comprehensive as that's been going for such a long time and so many people, you could pull any statistics out of it.
They are finding out so many things from the survey. This is just, I guess, the one example where the question was a bit vague, and because of that, the answers are a bit vague.
But it's also that, and it's sort of, why even bother publishing it? It's just a novelty. Perhaps you should publish it to show that you can create any statistics out of such a big survey that you want. You can get any cause and effect. You think about it.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.